Okay, hello everyone. Let's wait for a couple of minutes and then we can start. Can you confirm that you are seeing my screen?
Yes.
Yes, thank you very much. Okay, I think we are good to go. So good afternoon, everyone, and a warm welcome to today's Networking Friday session. I'm very happy to be here. My name is Eirini Marinou, and I am delighted to represent Geosystems Hellas in introducing this webinar. Thank you all for joining us. And whether you are here as a professional working in coastal management, could be a researcher from academia or someone from Port Authority representative, or simply just someone passionate about creating a more resilient and inclusive future for our marine and coastal regions. Um, OCEANIDS is indeed a European project, but we are very happy to collaborate with other countries as well and formulate collaborative activities together. So, what is OCEANIDS? Today we will explore the Horizon Europe project called OCEANIDS. OCEANIDS is an innovative initiative that focuses on empowering coastal communities and stakeholders through citizen-driven tools and applications. Our aim is clear: climate-informed maritime spatial planning. So what that means, we want to support better informed and integrated seascape management that helps build a more resilient blue economy. So our main objective is to harmonize and curate open climate data. The main outcome of the OCEANIDS project will be to contribute to sustainable blue economy and enhance ocean literacy. So what you will learn today. Now, let's take a moment to explain the heart of OCEANIDS project. This project is rooted in the principles of open data collaboration and inclusivity. It collects, harmonizes, and curates existing openly available climate data and services and makes them accessible, reusable, and interoperable. By doing so, OCEANIDS bridges the gap between global climate data and local adaptation needs, empowering communities to develop actionable strategies for addressing climate change impacts in their own regions. A key element of the OCEANIDS project, it is to focus on climate-informed maritime spatial planning, as I told you. By integrating data and tools into cohesive solution, the project supports sustainable decision-making for the preservation of marine ecosystems while enable economic growth at the same time. But Oceanid, it's not only about technology, it's also about people. The core mission of this project is to foster ocean literacy, helping citizens and stakeholders alike understand the importance of marine ecosystems. When we invest in education and awareness, we unlock the full potential of the blue economy while safeguarding our oceans for future generations. Today, we have a fantastic lineup of speakers who will share insights into OCEANIDS goals, technologies, and applications. First, we will hear from Charalampopoulou, CEO and President of Geosystems Hellas, who will provide an overview of the OCEANIDS project. So that means what it's about, where it stands today, and where it's headed. Next, we have Platon Patlakas from Hellenic Centre for Marine Research, who will introduce the core technology module for Data and Services Federation and Curation. And last but not least, we will have Daphne Pantousa from Resilience Guard, who will dive into the development of user-driven tools and application, showing us how OCEANIDS is working to meet the real-world needs. After the presentations, we will open the floor for a Q&A session, so I encourage everyone here in this webinar to ask your questions, share your thoughts, and engage in this discussion. So, to get us started with our speakers, I'm happy to hand the floor to our first speaker, Charalampopoulou, who will introduce OCEANIDS in a nutshell.
Thank you,
This-
Eirini, and thank you all for joining this webinar. Happy to see that we do have a lot of attendees, and this means that there is interest from everywhere for the coastal and port regions. So I'm going to share the screen and just to give an overview of the project. Please advise that you can see the screen.
Yes, full screen mode. Yes, perfect.
Okay. Sometimes needs to ask.
Yes, Betty, the floor is yours.
So, as the title says, OCEANIDS is a user-driven platform tool that will have applications and tools for climate-informed maritime spatial planning and integrated seascape for integrated seascape management. The task is to go in a resilient and inclusive blue economy. So it's an Horizon Europe grant of almost 3 million that started in December 23. We do have participation from several countries of Europe in order to have a good geographical distribution that is very much connected with the European climate zones. As far as we know, the problem of the climate change is everywhere. It's not only in South Europe, can be in Finland, can be in Belgium, and the maritime environment is suffering more because it's a heavy populated environment. It is an environment that, as add-on to the coastline cities, we do have the port cities and the ports. And because of the climate change, this is going to be enlarged the next period. So the monitoring and solutions that can be part of the decision support systems for the maritime environment are very, very important. So this is the consortium, as you see. As add-on to Geosystems, we have three organizations, European Association of Remote Sensing Companies, NIREUS and CDP. We do have companies, technological companies and technological institutes like OHB, IN2, ICCS, the University of Seville, RUTOC, Resilience Guard, Creotech, the Hellenic Centre of Maritime Research. But of course, and we do have with us a very large institute for meteorology, FMI, the Finnish Meteorological Institute, in order to help us in by viewing the climate change and meteorological changes in the coastal areas, and a law firm because we need to have rules under GDPR since we are involving a lot of end users. We do have end users from everywhere in Europe. We do have the Hellenic Ministry of Maritime Affairs and Insurance Policy, the Port of Heraklion, Crete, and the Prefecture of Crete, Air Center, the Region Bretagne, the Port of Rache, the Port of Satama, and the Port of Helsinki in Finland. And also, we have the region of Azores. We have the city of Malaga and the port of Malaga, and the Institute, ISL, the Institute of Shipping and Economies and Logistics, which is the partner that is serving the Bremen ports. So based on that, we, since the beginning, we have identified a great interest on the subject of OCEANIDS. Here is the distribution in the different countries. And because the OCEANIDS is a quite ambitious project, but it's using the user requirements as a tool to start giving applications and tools, we are securing that, like that, the tools given will be used, and like that, we can achieve a resilient and inclusive systematic pathway to the blue economy. Of course, it's technologically stands at the state of the art, since it will have a single access window platform in order in this platform to have climate-informed maritime spatial planning. It stands at the edge of the state of the art because inside the project we collect, harmonize, curate existing climate data and services, recycle them, make them to be accessible, reusable, and interoperable in order to help the development of local adaptation strategies. Last but not least, we want citizens and engagement. We want to promote inclusive and deliberate governance through meaningful engagement, dialogue between citizens and stakeholders in order to accelerate those transformative changes towards the climate resilience. The challenges are a lot. First, there is an increasing pressure on the coastal areas. This pressure on the coastal areas are coming because the coastal areas, they have high economic activity. This means that the ports and the coastal areas, because of the tourism, are much busier on the maritime traffic. So this is one topic to be taken in consideration that impacts the sustainability of the coastal zones. Second, the blue growth imperative means that we have to work with the maritime territories in order also not to stop the growth, not to stop the economic activities, because this gives jobs and good opportunities to the people that they work and live in those regions, but to make a kind of balance in the economic opportunities in parallel with the environmental sustainability. And also it's very well known that there are climate-related coastal vulnerabilities, means that by the OCEANIDS project, because we are monitoring all Europe, and all Europe has a very big coastline, and but for sure we know that a lot of kilometers of land located in the coastline is 1 meter below mean sea level. This OCEANIDS project get it as critical in order to further monitor it, and as critical as it is, and address it related to climate coastal vulnerabilities. First, in order to prevent problems, and second, to show the best solutions for the impacts to the economy and the society. As fourth challenge is the climate change. The climate change in the coastal regions is crucial for the growth of the coastal region, because there are industries, like I have already mentioned, the port industry and the tourism, but there are also the fisheries and the other kind of economic things that run in the coastal zones, and those risks are very much heavier the latest years, because the climate change effects are growing. So those risks poses problems to the infrastructures and local populations. The fifth problem, not problem only, challenge that we can mention is the need for integrated seascape management. Means that there is coastal governance, of course, but there are daily challenges, because those daily challenges might not be studied enough in the past. There is issues of coordination, diverse of knowledge, and lack of integrated governance in order to find a system which is seamless and can give a better and a sustainable coastal maritime management. Going back to the project, of course, the project has the, let's say, classic work packages, which are the work packages of management and communication, dissemination, and exploitation, but also have 4 real technological packages. Work package 2, that there is stakeholders identification and engagement. Work package 3, which is a core technology that has to do with modules for data and services federation and curation. Work package 4, it's user-driven tools and applications development. And work package 5 is the field activities, that all the results and the platform that is going to be produced, to be demonstrated, and all those tools to be validated with field work, in order that the tools to be efficient and correct to be used in the future. This is the zones, the climate zones that I have explained, that all end users, because there are many, are covering the climate zones, because the climate change is giving different results on different climate zones, and has to do with also the local meteorological and climate status, because there are, for example, in the blue zone, which is the Nordic, we have cold winters and mild humid summers. And in the orange, which is the Mediterranean, we do have the Mediterranean climate that the latest years is changing, and we have very hot summers and very mild winters. So we also use the Middle and Eastern European areas, which have Eastern continental climate, and we use the Western European areas, which we have the oceanic climate, because there we have the Atlantic zone, which gives totally different climate and meteorological inputs. I'm not going to go more by speaking about the zones, but the geographical distribution, the diverse characteristics of the climate zones are all studied in OCEANIDS project in order to go through in all cases with very concrete information to ensure a comprehensive and a representative approach, and to use all those criteria in the tools and in the algorithms running in the platform in order to facilitate all countries of Europe. This is the mapping of the use cases. We have a region Bretagne, we have the Azores, Malaga City and Malaga Port. We have the Bremen. We have the coastal Finland with 3 ports. We have the Greek islands with some areas that are already identified. And of course, we have the Crete region also, and the port of Heraklion. For example, by focusing in the Greek case studies and in the Spanish case studies, which are the Mediterranean end users, we can see that the climate risks are connected also with the sea rise level, the increase of the sea surface temperature, the increase in acidity, changes in phytoplankton, increasing number of marine dead zones, increasing multiple climate hazards, increasing risk of biodiversity loss, and of course, as I have already mentioned, we have the heat extremes, specifically speaking, in bigger heat extremes in summer periods. When we go in the Atlantic area, we have region of Bretagne, Azores, and Bremen. Bremen is not real Atlantic area, but it's North Sea. We have sea rise level, map. We have flooding, so we need to map this coastal flooding. We have strange winds. We have to forecast and map the winds. And of course, we have climate change risk with extreme temperatures and humidity. The latest years, we have seen temperatures very similar to the Mediterranean zone. We have increasing number of marine dead zones, and of course increase in multiple climate hazards, biodiversity loss, and we have in some cases problems with post-event earthquakes assessment. Also, we do have here in the Baltic area other kind of risks. We have ice problems at the sea. This risk was a usual risk in those areas, but now because of the temperature change, we have also ice movements that are quite tricky risks. We have problems with the air quality, and this has to be monitored. We have wind speed change and wind gust monitoring, and this have been better monitored and focused. We have changes in the depth, and we have changes in the waves, and we need to forecast also and map the large waves. And also to, because of, let's say, the risks of ice movements, etc., we have to monitor the ship movement tracking and also map and monitor pipelines routes. So in general, the challenges and motivation of OCEANIDS is in this panel, but I mean, it's duplicated, I think, in this slide. And last but not least, in order to go and go faster to the engagement of the citizens, we have been using a state-of-the-art method, which is a mobile application for citizen engagement and co-participation. This enables citizens and stakeholders in participate in one step, and like that we can accelerate the citizen and stakeholders participation and better understand the social tipping points. Like that, we develop the capability to create short-lived social networks. And also, there are open questions that are targeted in specific groups. And like that, to measure the acceptance of the climate-related initiatives, encourage behavior change, because all citizens have to adapt that, yes, we do have climate change. Yes, we have to monitor our coastal regions and coastal cities. And yes, as there are technological tools, we have to use them in order to make our life more secure, and like that, we can promote the OCEANIDS outputs to be better used, but also to better fit to the needs. So by going after to the main deliverable of the project, this is a screenshot of the OCEANIDS platform. This is giving Earth observation data visualization, is giving with specific artificial intelligence tools running behind risk identification, and can be a decision support system for mitigation actions, and of course, additional services. Last but not least, I have to say that OCEANIDS have been, let's say, recognized as pilot projects, so is part of the European missions for adaptation to the climate change, which is very good, because like that, we can have better visibility in Brussels. We can push more in the communication, and of course, we can be more visible to the persons that are giving political solutions in several cases. Just to say that these are the thematic missions that OCEANIDS is working with: the adaptation to the climate change and restore our ocean and waters. And I invite you all to go through the project and follow us by taking via the QR code that you see on the right, the project and the project results from now on. So I'm stopping my screen, and I give the floor I don't know if the questions will be at the end, I understand.
Yes.
I give the floor to the second speaker.
Yes, Betty, thank you very much. I hope now everyone has a good overview of what OCEANIDS represents, what it stands for, and what are the main objectives of the project. Now, next in line, we have our next speaker, Platon Patlakas. So if you are ready, please start your presentation, and the floor is yours.
Thank you, Eirini. Thank you, everyone. I'm really happy to be among you today here, and I will share my presentation right away. Can you see that?
Yes, we can.
That's great. So today we'll talk a little bit about our work package, and I will go through some slides really fast because I think they're as far as I get, they're quite covered by Betty. So the main project here is to collect, harmonize, and curate existing climate data services, making data accessible, reusable, and of course, interoperable for the development of local adaptation strategies. Our primary focus is ports, but why ports? Trade is the backbone of the global economy and prosperity. And as we all know, ports are the gateways to this, but we should have in mind that we are not only focusing on ports, but also in maritime route conditions, shallow water wind farms, and aquaculture sites and commercial fisheries. So despite the fact that our prime goal and prime investigation will be around ports, we are not working only on that. Our team is the team is here. The team belongs to HCMR and the Finnish Meteorological Society from a geoscientific perspective, and we have a lot of technical companies creating this work package, such as Creotech, IN2, CDP, ICCS, and Resilient Guard, Woodstock, and OHB, and of course the Geosystems. And our work package is actually quite interdisciplinary, with 3 out of the 5 tasks focused mainly in data analytics, data harmonization, and validation. And task 3 and 4 are focused more into a geoscientific component, like climate models and climate change impact, or meteorological models and seasonal impact in the ports and the maritime activities. Starting with the more, let's say, analytic component and the more computational component, we will be able to realize the full potential of Earth observation and non-Earth observation auxiliary geolocated data. And we will lower the barriers caused by the big data challenges, providing access to large spatio-temporal data, both to our partners, but also to our stakeholders. And we are already working on that. We have developed a system, and we are hosting this system online. And we are building these data cubes, which will be accessible both to our partners and the stakeholders through APIs. We will determine appropriate hardware configuration and software system components and automated AO data services components selection according to the user needs. We have already built some initial high-level architecture design, and based on that, we will ensure that there is this interoperability and easiness of use among all this data between all stakeholders and all people that are interested. I will focus a little bit more on the scientific component because this is my background and I feel more confident with that. We will focus on climate models, and we will forecast the climate change impact in coastal regions. And we have started working with extreme winds and extreme weights. And beginning with extreme winds, we know that they can affect the structural design, crane operations, and the cargo handling safety, while extreme waves can affect the structural integrity of offshore platforms in general, and of course, they can lead to erosion. We have selected several climate models. Actually, we have several ensembles, and we have started working on the extreme value statistics in order to quantify the potential of extreme winds to occur in particular locations. So using all this data and all these modeling samples, we can somehow quantify the associated uncertainty, and leading to some basic maps, such as you can see here, like the ones you can see here in this screen. Quantiles, meaning the extreme, let's say, component, the extreme parts of wind speed at 10 meters for the entire domain of interest. And this has been done both for historical analysis, but also for one scenario, the RCP 4.5 scenario in mid-century and towards the end of the century. By saying mid-century, I mean like from 2040 to 2070, and by saying towards the end of the century, I mean from 2070 to 2100. And of course, we have selected some particular locations, some ports of interest, which these are always updated. So we have more and more as we move on with the project. And here we can see the extreme value statistics for these ports of interest and of course for wind speed. And we can see the behavior of wind speed for different scenarios and different time periods for historical data up to data of what happens towards the end of the current century. And of course, we have performed this analysis for all these sites, and this is interactive, so someone can click there and see what's the behavior of wind speed for all these locations and return periods. And more or less the same procedure has been followed with waves. And here we can see the quantiles, the distribution tail, the behavior of the distribution tail of waves in nearshore locations for a historical period, of course, again, but also for two different scenarios now, the good and the really bad scenario, and of course for the mid and the end of the century. And we can see that there are some spatiotemporal variations, especially in the North Sea and Atlantic. And again, we have performed a similar analysis for the areas of interest, where you can see the behavior of the return periods distributions for selected locations. Here we have selected just for as a use case. And we can again see that for particular locations, we have either a huger and a more significant and more intense, let's say, wave climate coming in the future. But this is not always the case, as for some locations, we have either no big changes or even we expect a lower waves to be present in the future. And another way of how the weather can affect us and how weather can affect the maritime operations in general, not just ports, is through the concept of weather windows. And weather windows, what they tell us actually if the weather is so good for a large period of time, so we can proceed with particular operations. And these operations can be like operations of the ports or operations of the ships or wind farms or whatever we can have in mind that needs particular windows, particular thresholds in order to operate. So we have worked towards this way, and we are now able to both forecast into a from a seasonal perspective, but also to quantify from a climate perspective the of windows, the frequency of weather windows that are available in particular areas of interest. And this can give us an overview, a glance of how things will operate in the future. But we talked a little bit about climate data, but what I didn't tell earlier is that climate forecasting, climate data, climate models often lead to biases. They do not represent exactly what happens now. They have a lot of biases that these biases are a result of the models that and the processes that take part in order to predict the future. So, and because all this data affect our analysis, and we have proceeded with a particular technique in order to downscale and to bias adjust the data in into the ports, into the locations of interest. So we are using an artificial intelligence technique that takes into consideration a lot of things, not just wind speed, for example, as it's shown here. It can take into consideration temperature, precipitation, the topography, and of course the landscape. It downscales and it provides a local adaptation, let's say, to the data we are interested and in the area because the grid and solution and all these biases I was talking about earlier can affect our final outcomes. So the final aspect, the final, let's say, analysis will be performed on this data, and it will be performed on data that it's localized into the area of interest and has all the local features. And this is more or less how it looks like, and we have been working on that, and it shows that we have seen that we have actually a great improvement in most of the sites. But we should have in mind that that's not always the case, because as we all know, observations are not always available. So we will prioritize locations and ports where we have full observations. We will go with the full capacity of working with this AI technique. And then we will do the best we can with locations that there are no observations available. And of course, we will gather everything from all these data sources, open data from EMODNet, Copernicus, etc., and data that will be produced from this project, from the current projects such as OCEANIDS. And we will gather everything. We have started gathering everything, but as with the project moves, we will have more data ingested, and we will integrate everything into and develop a repository, and of course an API in order to be able, use this user-friendly application for people to download everything and to process everything and to have a glance and overview of everything. And that's all about our work package. And thank you for giving me this time to present everything.
Thank you very much, Platona. So everyone, in the meantime, if you have any questions about the presentations, please just take a note and we will see you in the Q&A session. Also, I would like to say hello to everyone who is introducing themselves on the chat. I'm really happy that you're writing where you come from, your name. And now we move on with our next speaker, Daphne Pantousa. The floor is yours. So please share the presentation.
Thank you. Can you hear me?
Yes, we can.
Okay.
Loud and clear.
I'm glad to be here today and participate in Networking Fridays. Now I will share my screen. Just a moment. Okay. And so, can you see the presentation?
Just give it a second. I cannot see something.
Okay.
Yes, now.
Oh, okay.
See
Just
your
a
screen.
moment. Yeah, okay. Now it's okay. Okay.
Yes, perfect.
Okay,
perfect.
thank you. So today I will presenting OCEANIDS user-driven tools and applications which are developed under Work Package 4 of OCEANIDS project. First of all, I want to highlight that this is a collaborative effort and including Resilience Guard, which I represent, OHB and Geosystems Hellas. Our goal is to develop a comprehensive platform that integrates urban and maritime spatial planning with climate adaptation planning through advanced data-driven tools. The core innovation lies in creating a multimodal decision support system that transforms complex climate data into actionable strategic planning insights for coastal regions. Here we can see a screenshot of the platform, and at this stage I want to emphasize that this platform is still under development, so what we're seeing here is just mock-ups. First, it is important to explain that the platform consists of 3 components with specialized functionalities. The first component is the climate change risk and hazard assessment platform, which will be developed by Resilience Guard. I'm sorry. And this component employs sophisticated multi-scenario modeling to evaluate potential climate risks across different temporal scales. The second component is the OCEANIDS decision support platform, which will be developed by Geosystems Hellas. This component provides operational optimization specifically for coastal regions. It uses machine learning and predictive analytics to generate climate impact recommendations. And the third component is the integrated Earth observation platform, which will be developed by OHB. And this platform is actually a single access window for spatially enabled data, utilizing advanced geospatial visualization technologies. This figure demonstrates the interconnection of the components. We can see that these components engage in complex interactions, as presented in this diagram. And in the next slides, I will provide an overview of the functionalities of each component. The first component, the risk and hazard assessment platform, will be tailored to the needs of regional stakeholders. By developing algorithms and that can process multi-source datasets, the potential risks and hazards will be evaluated. These outputs will enable regional stakeholders to shift from reactive to predictive climate adaptation strategies. This risk assessment methodology operates through 3 different modes. Each mode has unique characteristics depending on the varying level of a scenario uncertainty. The long-term mode uses stochastic modeling to generate probabilistic scenarios with maximum uncertainty. This mode uses long-term climate projections. The short-term mode integrates forecast data which constrain and refine the potential scenarios and outcomes, while the post-event mode utilizes forensic data analysis and the uncertainty, of course, is minimized. The long-term mode considers, as I said before, a wide range of possible climate scenarios. Some key technical features include the scenario generation, predictive modeling of assets response, multivariable analysis, and finally the impact evaluation. So this approach, this mode, will allow the users to visualize a variety of future scenarios and their potential impacts. The short-term mode has the same architecture with the long-term mode, but focuses on forecasts to narrow down the range of possible outcomes. In this way, regional stakeholders will be able to make more immediate decisions in the face of the upcoming climate-related risks. And finally, the post-event mode operates with a least uncertainty, as I explained before, and it evaluates a single actualized scenario. The outputs of this mode will help stakeholders assess impacts and understand the event's consequences. The climate hazards that will be considered include the earthquake, flood, sea level rise, wind, temperature, and humidity for the long-term mode, the wind, temperature, and humidity for the short-term mode, and the earthquake, floods, sea level rise, and wind for the post-event mode. The assets which may be vulnerable to these hazards can be structures in ports like warehouses, office buildings, terminal buildings, cranes, storage tanks, container yards, power substations, and equipment in general, and many others, of course. And the final outputs are the potential direct and indirect economic and social losses. The second platform, the second component of our platform is the OCEANIDS decision support platform, which represents a computational ecosystem designed for climate adaptation optimization. Actually, this platform will provide recommendations for mitigation and emergency response measures in the regions of interest, leading to subsequent multi-scale planning. The architecture of this platform includes actually 4 steps. The first step is the data processing by integrating multi-source data sets from OCEANIDS partners. The second step is the machine learning model training. The third step is the predictive scenario generation, while the fourth step is the adaptive recommendations engine. And finally, the third component, the integrated Earth observation spatial data platform, serves as a sophisticated computational nexus. This platform will act as the central access point for the end users and will provide a user-friendly interface for easy access to a diverse range of information, data products, and metadata provided by the other components of the platform, or Earth observation services related to climate change data. So this platform will visualize either the Earth observation data or the outputs of risk and hazard assessment platform and decision support system. Here we can see some examples of Earth observation data that will be available, may be available through our platform. And we have a large variety. Some examples are the large waves, the ocean level and surface, ocean widths, and many, many others. And finally, here are some mock-ups of the platform are presented here. The login to the OCEANIDS platform will be handled through an authentication and authorization framework, such as the keylog. The users may select between first they will select the pilot area, and then choose between the visualization and analysis of Earth observation data and spatial data, or the option to specify requests for risk assessment and decision support. So the user actually has 2 choices. Having selected the second choice, which is the risk assessment, potential options such as peril or return period will be displayed. Then polygons of sections in the pilot area will be displayed on the interactive map, colorized dependent on the respective risk scores. By clicking and hovering upon the risk polygons, the user may select and get information about the respective polygons, such as the risk scores. Having selected a polygon, the user can open a toolbar to parameterize and execute a request for decision support. And finally, here we can see the other option, which is the visualization of Earth observation and spatial data. So the user will be able to visualize the Earth observation and spatial data in order to supplement the risk assessment and decision support. And in this slide, we can see the example of heat, of the peril of heat. Finally, we are planning to add new Earth observation services, which will depend on the user needs. This could include functionalities such as the classification of the hottest areas in the coastal regions, or gathering time series of temperature data for specific locations. As I explained before, the platform is still under development, so these are issues to be discussed. Thank you very much for your attention.
Thank you very much, Daphne, for your detailed presentation. It was really interesting. And now I would like to share. Okay, Daphne, if you can stop sharing.
I'm trying.
Yes.
Okay. Stop. Okay.
Yes, thank you very much. And I would like to share my screen again. as we dive into the Q&A session. Okay. So firstly, I would like to say a big thank you to all the speakers for their insightful presentation. It's actually very inspiring to see how all the innovative work being implemented in OCEANIDS in order to support the sustainable coastal management and resilience. So having concluded with our speakers' presentation, we are in the Q&A sessions. So please, I would like to ask from the audience, this is your opportunity to ask any questions, you share your thoughts, or seek clarifications for something that you heard today. So please feel free to type your questions into the chat box, and we'll make sure that they are addressed by our speakers. So to get us started, I have a few questions prepared for our panelists while you think of your own. I don't know if we have any questions in the Q&A. I cannot see it.
Actually, I can see a couple of
We
questions.
have.
Yeah. Can you see that, or should I?
No, I cannot, unfortunately.
Maybe, I don't know. Okay, I don't know if the question is towards me, but the first question says very interesting. There is many work behind the development of a model. What are the main constraints to build a model that is representative and adaptable to different regional areas? I think that would go towards me. And I guess you're talking about an AI model and not a climate model, because that can not be adaptable to different regional areas for sure. So the biggest constraint is observations, actually. If we have observations, the more observations we have, the easiest is for us to apply all the techniques and to perform this this downscaling and this local adaptation using our AI model. So if this is solved, if we have all the information we need, if we have all the observations we need, and for a large period and of a good quality, of course, then we can apply our model and do our downscaling, and we can adjust the climate data into the area of interest. And that's all. I mean, that's all we need for now. And of course, computer resources, but we consider this is something we already have.
Yeah, thank you very much, Platon. And if I may add on this, actually, in a more general perspective, building indeed a model that is representative and adaptable can indeed face several challenges. And I can add on in your own, like data availability and quality, because there are many constraints on that, as many regions lack reliable data sets. We also have regional differences in environmental and cultural characteristics as well. And we also need to ensure data interoperability. And of course, I don't know, usability is also key. So the project to involve users also in the design process. Yeah.
I can see a second one again. I don't know if I'm the only one who can see these comments.
I can see also the questions. Yes.
Okay,
I found them.
Yeah,
Okay.
please go
So
on.
the second one is from Sanusi Mohammed, and he says, is the platform for commercial purpose or for private use? I mean, maybe Yuma, Eirini, and Vasiliki, Betty can answer that.
Betty, would you like to comment on that? You are muted. Can you? Yes.
Yes, I was trying to see the question, but by the way, I cannot find it in my chat, but there is no problem. It is a European project, so the platform is open to all European Union citizens. On top of that, if there are requests that are coming outside Europe that needs also to integrate data from other regions, of course, there will be a kind of commercialization. Otherwise, for Europe, because it's funded under a European Horizon initiative, is open and it's open access.
Yes, thank you. Thank you very much. Do we have any other questions until now?
Not that I can see. Actually, the Q&A box is just next to the share box, maybe, but I cannot see anything else. That's all.
No. There are just two questions. Both of them have been answered.
It's perfect. But I have prepared some for our speakers. So this can possibly answered by Betty. So from your perspective, what are the most significant barriers to promoting ocean literacy among our stakeholders, and how does OCEANIDS aim to overcome this?
It is, in my perspective, the bigger barrier and the higher problem in order to put stakeholders to use and citizens to use OCEANIDS and better understand the OCEANIDS output is that, first of all, in many stakeholders are still using traditional ways to face some problems. Means that they are not forecasting, they are not monitoring, but they try to face the problem when the problem is there. The second is that they use, by using traditional methods, they don't use a lot of digital and digital tools, which the digital tools is, for example, the platform that have artificial intelligence and is a kind of decision support system in order to be faster and more effective. So, in my point of view, we have to promote the use of new technology, state-of-the-art digital technology that can help, and to be proactive means that we need to monitor and forecast in order to get actions before something happens. So like that, we will have a more sustainable and more resilient society. And this is something that we would like to have as a result of the OCEANIDS, since we want that OCEANIDS platform to be used and to be a sustainable ICT tool for the next years to come, not only during the project.
Yes, exactly,
That's
Betty.
all from my side.
Exactly, Betty. Yeah. I can move on with a question back to Platon if there are no other questions from the Q&A. So Platon, given the variety of climate data sources, how does OCEANIDS address challenges in harmonization and curating data for seamless integration into local adaptation strategies?
Okay, I think this is a two-step approach. First, we are proceeding with data standardization through the concept of data cubes. So we ensure that all climate data, no matter what is the source, everything is delivered in standardized formats, both for our partners and stakeholders. And the second component actually is the local adaptation techniques we're performing through the AI modeling. So in this way, we adapt the data to local conditions. And these two components actually help us both capturing the real, let's say, aspect of the climate data, and to deliver this data in a user-friendly way and standardized for all potential data, no matter if it is climate or Earth observation or other.
Yes, exactly. So do you possibly think, just a question that popped up, do you think that if someone is interested in following OCEANIDS initiatives and try to be adaptive in a way, will this be possible through the technologies and the solutions that OCEANIDS is developing?
Sure, that's a definite yes. Of course, we're working. I mean, we're trying to keep interoperability among us and among the stakeholders and among everyone. So, of course, we can adjust to the needs of the people, with the needs of the stakeholders. And this is maybe one of the most challenging things we faced during the start of the project. But I can tell with for sure at this moment that we have achieved we have improved, let's say, our way of thinking and comprehending everything. So we are there, and yes, we can adjust to whatever the needs of stakeholders and people that are interested in our project.
Thank you very much, Platon. And I have prepared another question for our last panelist. So Daphne, you discussed user-driven tools and applications. So how does OCEANIDS engage end users during the development process to ensure that those tools are practical, effective, and tailor-made to their needs?
Yes, our strategy is to organize focus groups and workshops to demonstrate the stages of implementation of our platform and discuss with the end users and discover their needs. And actually, we have already discussed about organizing a workshop on January. We discussed this, you remember, in our second plenary meeting. And in this plenary, we will present the mock-ups of the platform and discuss with the end users in order to see how they understand this and what they need more, if they need something more, etc.
Daphne, you mean the workshop on March, probably?
No, we discussed, you remember, with Joris to organize a small workshop.
The smallest workshop.
Yes, the smallest.
Indeed. Yes.
This will be just to discuss with end users about their needs
exactly.
and help them understand what we are doing in this platform.
Perfect. Thank you very much, Daphne. Do we have other questions in the Q&A session? As you can see. No, probably. So yes, we do not have any other questions for our panelists. If you don't have any other questions, okay, thank you everyone for joining us today in today's Networking Friday, and also for contributing with your questions to this engaging discussion about OCEANIDS and its mission to foster resilience and inclusivity in coastal regions. I would like to say a big thank you to our speakers for sharing their expertise and insights. It's pretty clear that OCEANIDS has the potential to make meaningful impact on sustainable coastal management and the blue economy. I really hope you found today's session informative and inspiring. And if you would like to learn more about the project or stay connected and engaged, through the process, please do not hesitate to reach and visit the OCEANIDS website. You can scan the QR code on your right. You can email me every time. I'm available. I can help you and I can keep you engaged in this journey. And you can also find us on LinkedIn. And yes, thank you all for joining. And I would like for us to keep in touch.
Thank
you,
you
everyone.
all.
Thank you all.
Thank
Bye-bye.
you.
Bye.
Bye. Bye.